Broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to today's webinar on why your MySQL needs Redis. This is Christina Cardoza, news editor of SD Times. Before we get started, I have a couple of housekeeping announcements. First of all, we will be conducting a live Q&A after today's presentation. If you have any questions at any time during the presentation, you may submit them through the Control Panel's Questions tab. Secondly, this webinar will be recorded and available on demand through the sdtimes.com website in about 24 hours after the event. Here at SD Times, we've been writing about the influx of data and how organizations can manage and organize that data to better their business. MySQL is a relational database management system used to store and retrieve data. Today's presentation will look at how you can complement MySQL with Redis, along with tips for designing look-aside and write-through caching solutions, session stores, and rate limiters. Here to discuss this further is Roshan Kumar, Senior Product Marketing Manager at Redis Labs. Roshan has extensive experience in software development and marketing in the technology sector. In the past, Roshan has worked at Hewlett-Packard and many successful Silicon Valley startups. As an enthusiast programmer, he designed and developed Mindzeal.com, an online platform hosting computer programming courses for young students. Now to get things started, I'll turn it over to you, Roshan.
Thanks, Christina. Hello, everybody. Thanks for joining the webinar today. We have a very interesting agenda, and I have a lot of material to cover. I'll start with a problem definition, and this will set the stage for the rest of the discussion. And I'll give a brief introduction to Redis. For those who are new to Redis, we'll talk about why Redis is so popular. It's now one of the top 10 databases in the world. We'll see why it is so popular. And then as a front-end database, I'll talk about 4 use cases, and this is going to be a bit technical. I'll cover 4 use cases: caching, session store, rate limiting, and fast data ingest. And if you have any questions, feel free to ask questions, but I'll take the questions towards the end. But don't hesitate to ask questions. I'll definitely answer most of them towards the end. Okay, let's start our discussion. To set the stage again, this is a sample architecture that we will refer to throughout the discussion today. And what you see here is a solution. A solution may have a bunch of applications, and all these applications are connected to a backend database. And for the sake of our example, we'll consider the backend database to be MySQL. And typically, all these apps, they talk to a database through an abstraction layer. Let's call it data access layer, and some people call it data link layer. Whatever it is, usually there is an abstraction layer between the apps and the database. In some cases, they may not be abstraction layer, but for the sake of example, we'll assume there is an abstraction layer. And also, we'll also assume that there are many users who connect to these apps over the internet, and these apps could be mobile apps, or they could be some web app, or whatever. But we'll assume there are many users who use these apps over the internet. So this is the sample architecture, a very high-level architecture that we'll refer to throughout the discussion. Okay, given that architecture, that's very plain, simple. Now, what happens in the real world is this architecture needs to adapt to a lot of moving things. First of all, any enterprise, or most enterprises that are out there today, they have to support more users over a period of time, and they introduce more apps. They could be in-house apps, or they could be consumer apps, apps for the channel distributors. There could be so many ways, or there could be so many apps that could be built in the ecosystem of enterprises. And typically, all these apps, they talk to a single backend system. We call it a database, and we have typically seen MySQL used in this context. And all these apps, they talk to the same MySQL database, and this is the monolith architecture. And over a period of time, there is more data. There are more users, more apps, and more data, more tables, more schema, and more things to manage, and this becomes very expensive. Now, let's look at 4 challenges with this context. What happens when you run into this situation? The first challenge is there is more data in the back end Of course, there are more apps, more users, and over a period of time, you're collecting more data. And of course, you're going to have more pressure on the database, and the database has to run many queries, and it has a large data set, and it becomes really complex. And what app developers and what the architects do in this situation typically is they add more resources to the backend system so that they can run more queries and they can hold more data. They add more storage, and it becomes very, very expensive in the backend. So that is challenge number one, how to minimize the cost of data management while scaling. The second problem is how to get more apps to the market. We live in a competitive world, and most enterprises, they want to get apps, they want to stay ahead of their competitors in the business. So they have to add more apps. For example, we have Home Depot as our customer, and to stay ahead of all competition, they introduced about 20, 30 apps in one calendar year, and that is a significant development on their part. And in such situations, how do you add new apps without breaking the back-end system? So that is a big challenge. The databases, especially the relational databases, they're rigid. They have tables, they have constraints. And to add a new column, you have to change the schema. And to change the schema, you have to go through so many approvals. So it becomes a nightmare. So the challenge is, how do you add new apps and new functionality without really disturbing the backend system? So that is challenge number two. Challenge number three, it has more to do with how people interact with apps. And we live in an on-demand world, and people want quick response. So they ask for it, and they want to see a quick response. And some studies have shown that for a highly engaging app, the maximum latency you can have is about 200 milliseconds. The problem here is, out of those 200 milliseconds, most of the time is gone in the network latency. So for the app and for data access, you are under pressure to deliver all the data with sub-millisecond latency. So how do you do that? So that is challenge number three. So challenge number four, again, I'm going back to our Home Depot example. They had a legacy database system, and they added about 20 apps in a year, and they had more users. So there are more users, more apps. They're all talking to the same database system in the backend. During peak hour, the backend database could not take the load. The backend database it had the capacity to take about 30,000 ops per second, but during peak hour, they saw that they were hitting something around 50,000 ops per second. And unfortunately, the database could not take that load, and there was a cascading effect. It was not just one app that failed. Since the database failed, almost all the apps became dysfunctional over a short period of time, and this was not good. So in such situations, you can introduce Redis. That's what I'll talk in a short while. And they had a solution using Redis, and they used Redis as a rate limiter, and they fixed their problem. Okay, and let's see. So these are the four challenges, and just to have a philosophical quote here, it is not the load that breaks you down, it is the way you carry it. It's a very philosophical quote, and it definitely applies to our situation here. So how can you solve this situation, solve this problem? So we talked about four challenges, and you can address these four challenges by introducing Redis. So you can insert Redis behind the apps, or you can insert Redis. Did I lose connection? Are you able to see?
Yeah, okay.
You can introduce Redis just behind the apps, or you can introduce Redis behind the data access layer. So in either cases, you can boost the performance of your apps, and without really interrupting your backend database system, you should be able to manage all your apps without hurting your database. Right? Let's see how we can do that. Now, before we do that, in the interest of those who are new to Redis, Redis is an open source in-memory database platform. It's one of the most powerful databases in the market today. It is extremely popular. And about Redis Labs is the main sponsor. It's the only sponsor of this open source project. Redis Labs also delivers Redis Enterprise which is built on top of open source Redis. And Redis Enterprise is mainly meant for enterprises. It makes the it brings in operational efficiency into Redis. It gives you a nice UI, a nice user interface to manage all your Redis services. You can scale really well, and we give you high availability. You can do active multi-master database, and so on. There are many things. And if time permits, I can go deep into that later during this discussion. So overall, Redis is an in-memory platform which is extremely fast, and it is known for these three things. First of all, performance. I'll talk about performance, more about performance on the next slide. The second thing is, it is very simple to use. If you're a programmer, Redis has built-in data structures. It has sets, lists, sorted sets, and many other data structures that you need as a programmer. And these data structures are heavily optimized, and any commands you run on these data structures, they are optimized to the order of n or log n. So you're assured of operational efficiency. And then Redis is extensible. I'll give an example. Redis has this modules API, and you can develop your own modules, or you can take some of the modules that are available off the shelf. For example, there is Redis search module. You can import a Redis search module to your Redis database, and your Redis database becomes a search engine. There is a graph module. So if you want a graph database, you can just import the graph module, and your Redis database becomes a graph database. So there are many more modules. You can go to redismodules.com and see all the available modules. They're all open source, and you can just import those modules, and you can convert Redis into the type of database you want it to be. Okay, more about performance. Now, Redis is known, since it runs in memory, it's known for high performance for both read and write operations. An Avalon Consulting Group, a third-party group, it ran some benchmarks against some of the NoSQL competitors. And what Avalon found was Redis Enterprise had the highest throughput, and this is for write operations. And also, it has the least latency. So what you see on the left side is a chart that describes that. The bars, they show how many operations were done per second, and you can see the line chart, which shows the latency. So Redis had the best performance, Redis Enterprise had the best throughput, and it had the least latency compared to the competitors. And then there is another dimension to this whole thing. Now, Redis gives you the highest performance with least latency, and it does this with the fewest resources. So that is another important dimension. That's what you see on the right side. This is published on Google. Now, on Google Cloud Platform, Google did some benchmarks using Cassandra, and they showed that you can do 1 million writes per second on Google Cloud Platform using Cassandra database. And they showed that you can do this with 300 servers. Couchbase took that as a challenge, and they ran the same benchmarks on Google Cloud Platform using the same type of servers, but they showed that you could do, you can run the same number of writes per second with just 50 servers. Redis Enterprise also ran the benchmarks, and with Redis Enterprise, we were able to show that you can run 1 million writes per second on Google Cloud Platform with just 2 servers. So that is that's the throughput, and that's the efficiency we bring on the table. And what you can see here is the cost that's associated with so many servers. If you need something like 1 million writes per second, and Redis Enterprise has the least cost. And with this, Redis is popular for all these use cases. And the use cases, they range from caching to session store, high-speed transactions, machine learning, analytics, and it goes on. There are many, many use cases. And today we'll talk about 4 use cases, but there are many use cases that Redis is popular with. Okay. Now, the main crux of this discussion, Redis as a front-end database. How can you complement Redis with any legacy database, any database like MySQL? It can be any legacy database, MySQL or Oracle or DB2 or anything. So you can complement Redis. You can put Redis as a front-end database, and then you can use it as a complement without really disrupting your back-end system. Okay, we'll talk about 4 use cases: cache, session store, metering, and fast data ingest. We'll go deep into these use cases right now. Okay, Redis as a cache. Caching is perhaps one of the most popular use cases of Redis. And there are 2 popular ways to implement cache. There is something called look-aside cache, and there is a write-through cache. But in general, cache is used for frequent reads and infrequent writes. For example, if you're watching Netflix, if there is a popular program on Netflix, there is a big population or there's a large set of audience that watches the same program. So it's a good idea to cache all these popular programs. So that's the idea here. Now, if there's something that's reread frequently, which is something that's popular, something that's shared between users, rather than fetching that data every time from the backend database, you can just put that in Redis and fetch that from Redis whenever. For the first hit, you always go to the backend database, but for all subsequent reads, you can read from Redis. So that's the idea. In case of write-through cache, the life cycle is if you're updating this data, you update Redis data too. But in case of look-aside cache, you don't care about updating the cache. You just update the backend database. But what you do is you can expire keys in Redis. We'll see that on the next slide. So you need to manage the data in Redis. You need to set some expiration time for the cache. Okay. So let's see the steps. And these are the steps that we recommend as best practices. So if you are planning to design a new cache solution, we suggest that you follow this 6-step process. And it's very easy for you to implement a caching solution. It's extremely easy. You just need to follow these steps. So first of all, in your database, you should identify all the data that is repeatedly read. And once you identify that data, you need to know how you are going to access the data once you put that data in a cache. So you need to have a key. The cache is nothing but a key value store. So if you're caching your data as value, there should be some structure, some understanding on the key structure so that you access the data using the key. So that is the step number 2. And then you need to get the right data structure. And as I showed you earlier, Redis has some built-in data structures. So you choose the best data structure that you need for your cache. The next thing is you need to have a time to live. The data in cache goes stale after a period of time. So you need to set a time to live, and you can do that in Redis. You can set a time to live, and after that, the key and the value just expires. It just vanishes. So you need to do that. And the 5th step is a very important step. It is that you need to decide on the eviction, or you need to have an eviction policy. You need this because if your memory gets full, now Redis is an in-memory database, and if Redis is full, or if you have used all of your RAM, and if there is no space available in Redis, Redis has some built-in eviction policies. There are some 7-8 eviction policies. So you can select the one that suits your needs, and you can have an eviction policy to evict all the data once the RAM is full. So that way you can manage your cache. And the last one is you need to implement the read and write logic. If you're having a write-through cache, you need to have a write logic. And if it is read-only cache or look-aside cache, you should implement the life cycle of fetching the data from your backend database, storing it in cache, and then reading all the subsequent or running all the subsequent reads from Redis. So these are the 6 steps that we recommend. And to take an example here, I have a product table, and you can see on the product table, I'm caching each row. You can see in this example, I'm using the hash data structure. And now if I'm reading, let's say, product with ID 1,000,003, the first time I read from the MySQL database. I read the whole row. And when I read it for the first time, I read it from the MySQL database, and then I put it in Redis, and I store it in the hash data structure. And I have all the data here. I'm pulling the whole row, and I'm putting it here. And then suppose I'm running queries. This is another example. Suppose I'm running queries based on price. What I can do is I can fetch all the data, or I can fetch only the IDs, and I can use a sorted set and use the price as the score for my sorted set, and I can put all my products into this sorted set. So I can run a query. I'll show the next slide how I can run a query on this sorted set. So this is another way of caching the data based on price. Okay. I'll show some query examples right now. In the SQL example, select star from product where ID is 1,002 or 1,000,002. The equivalent here is if I have already cached this product, all I need to do is get all product underscore 1,000,002. You can use underscore as the delimiter, or you can use colon as a delimiter. Usually, colon is a more popular way of using Redis. I'm just showing here an example. I'm just using underscore as a delimiter. In the next example, if I want to just fetch the name of the product where ID is 1,000,003, I use the Redis command get product underscore 1,000,003 n. So what it does is it looks up this hash data structure, and it gets just this element, which is the name. Okay, and in the third example, what I'm doing is I'm getting all products that are priced less than 300 pricing units. And as you see here, I'm caching the data based on price using the sorted set data structure. So what I do is I run the command z range by score product price 0-300. So I'm fetching all the products that are in the range of 0 and 300. And once I get all the products, I have the IDs, but I need to get the whole row for all these IDs. So what I do is I run get all on each of the items that fall in this range. So I run a series of get all commands on this key to retrieve all the information related to that product. And since I'm running this set of queries in memory, this is going to be much faster than running a select star query. Even if it is a prepared statement, the latter is much faster. Okay, and I'll show some query examples where if you're using a write-through cache, these are some of the examples of writing the data back to the cache. For example, if you're inserting a new product, in SQL you use insert into product values so-and-so. In Redis, there is something called multi-exec. So what you do is you put all the commands between multi and exec, and it becomes an atomic command. And here in this case, what we have to do is we have to update the hash data structure, and we have to update the sorted set data structure. We need to update both of these because we are caching our data in both of these data structures. So what I'm doing is I'm using multi-exec, and I'm using the command hmset to set new or to insert a new hash data structure, and then I'm doing a zadd. I'm running zadd command to insert a row into the sorted set, product price sorted set. So that's the equivalent. Now, if I'm updating a row, and the first example is about inserting a new object, but if I'm updating a row, let's say I update price of a product. Here again, I can use a multi-exec, and here I use hset. So instead of hmset stands for hash multiple set, but hset is you're just inserting, you're updating just one object inside hash. So I'm doing hset to this product, and I'm updating the price to 400, and then I need to add this item on inside the sorted set data structure as well. So I'm running this inside a multi-exec. So this is the equivalent of updating a product in a row. Okay, so that's about caching. So just to recap, we talked about two types of cache: look-aside cache and write-through cache. And these are the 6 steps to design cache. And we saw some examples on how you can get equivalent commands in Redis and how you can cache these objects in Redis. Right? Now, the second use case we talk about is that of a session store. Many people get confused between caching and session store. Now, session store is very different from caching. Now, in case of cache, all the data that you cache is shared between all the users, whereas in session store, only a particular session can access this data. And also the life cycle is a bit different. I'll give an example. If you use TurboTax for filing your taxes, Intuit is our customer, and what they do is when you log in, they get all your tax return information into session. They load all your data into session, and while your session is on, the read and write happens only to Redis database. It doesn't happen to the backend database. But when you log out or they have some periodic synchronization, they write the data back to the backend database. But while your session is on, the read and write is only between your session and Redis. So that is the life cycle here. And the data is totally isolated between sessions. So if there are multiple users, there could be millions of users who are active, and these sessions are completely isolated. And if I add things to my shopping cart, nobody else can see what's in my shopping cart. So that's the idea here. And we have some examples here, the many uses of session store. And let's see how you can design a session store. It is kind of similar to caching, but there are subtle differences. For example, here the data doesn't go stale. So you cannot have a timeout on the data, and you cannot have an eviction policy, because as long as the session is on, the data is active. And you put the data, you synchronize the data back to your backend database only after the session ends or a period of time. So there is no concept of data going stale while the data is in session store. Again, the steps: identify the tables and determine the Redis equivalent data structures. These two are same as you do with cache. And then list the queries, develop Redis equivalents, and then decide the procedure to load the session data and resynchronize the data back from Redis and MySQL. So there should be some way you should agree on how you're going to load the data to Redis and how you're going to synchronize the data back to your MySQL database. So that is something that depends on your use case, and you have to decide how you're going to do that. And once you do that, you can modify your data access layer. In this example, I have a sessions table and I have a shopping cart. So there are two tables, a sessions table and a shopping cart table. And the idea here is each session has a row, and the session adds items to the shopping cart. And for each session ID, you have products that are in the shopping cart along with quantity. So that's the idea. And the Redis equivalent here is, for sessions table, you have hash data structure. And for shopping cart, you are going to have a separate sorted set data structure for each session. And that's how you isolate sessions. If I'm a user with session ID 192.730217, I can access the data that's only in this sorted set. So that's the idea. So you have a separate sorted set for each session, and you isolate each sessions this way. Right? And let's look at some of the query examples. Select product SKU quantity from shopping cart for a given session. Here it's very easy. You just need the product SKU and quantity. So you have that information in the sorted set. All you have to do is run Z range by score, and I'm fetching all the elements here. So I can do a Z range by score with 0 to infinity with scores. So that's one thing. Or if you have a lot of items, if you have millions of items, you can use a command called zscan. We don't recommend that you should use Z range by score if you have a lot of items. Now, Z range by score works really well if you have a small set of items. The other idea here is if you're inserting into a shopping cart, let's say you're adding stuff into shopping cart. In SQL, what you do is you do insert into shopping cart with given session ID, product SKU, and quantity. And here, the equivalent in Redis is zadd, and you are adding to a shopping cart sorted set with quantity and ID. So that's the idea. Okay, so just to recap what we did for session store, the life cycle is a bit different. The session data is isolated between sessions. It's not same as caching. The design of session store is a bit different. You cannot evict the data, and the data doesn't go stale. So you need to have large enough space to hold all the data. So you have to plan for your peak usage, or you can use something like Redis on Flash that comes with Redis Enterprise if you're an enterprise user, and that way you can hold large set of data. So you cannot evict data, you cannot make the data stale. And we saw some query equivalents for session store. Okay, and the third use case we are talking today is about metering. Metering is a very interesting use case. As I said earlier, Home Depot had a problem where they were hitting the backend database with about 50,000 ops per second, but it could take only 30,000 ops per second. What they did was they did a brilliant thing. They just introduced Redis in between, and they implemented a very simple rate limiting algorithm. Very, very simple algorithm. I'll show you how you can do that. And with Redis, it's very easy to do a rate limiter because it has built-in counters, and it has the concept of time to live. And also Redis is a single-threaded architecture, so you cannot have multiple threads changing the data, and that you get into conflict. So you're always conflict-free, and if you're updating data, you're assured that the data is consensus-free or conflict-free. Okay, let's see a simple example for metering. So this is what Home Depot did. And in this example, I just bumped up the number to 300,000, but and it's 300,000 per minute. But you can play around with the numbers here, and you can just set it to 30,000 calls per second the way you want. So the idea here is you're setting a counter. So this INCR is a Redis command. It's a counting command, and if the counter does not exist, Redis initializes that counter to 0. So if the counter doesn't exist, it first initializes that to 0. If the counter is less than the limit that we have, you get into this loop, this if loop. And if the counter is 0, that means you are getting into this loop for the first time, and that's when you have to set an expiry on expiration on the key. So you expire the key for 60 seconds. So that's what we want. So we want to allow 300,000 calls per minute. So here I'm expiring this counter for 60 seconds. If you want to have some other algorithm, if you want to limit to 30,000 calls per second, all you do is you put 30,000 here in the counter, and you expire the key every second. And endif, and you can run the DB query here. So what happens here is, if the counter exceeds your upper limit, you won't even get into this if loop, into this if condition, and you won't run the DB query. And what happens after the stipulated amount of time? The counter expires, and it gets reset to 0 here, and you get into this loop again. So it's as simple as this. So initiating and running a rate limiter is as simple as you see here on the screen. And we have some sample rate limiters on GitHub. Again, these are just to seed some ideas. Feel free to download them and play around. This is all written in Java. We have a generic cell rate limiter, and it follows something like a leaky bucket algorithm. It's a very easy implementation of rate limiters. You can go here and you can see some examples. Meanwhile, I'll show a quick example of how rate limiting works. So let me show this here on the screen. So this is a generic cell rate limiter, and let me open this up, and I'll just run this and I'll show how this works. So the in is all the commands that are coming in, and out is all the commands that are going out. So what I have is I have a window of 20 seconds, and in those 20 seconds I can take only 20 actions. So that's the idea. So what and if I want to make it, let's say 40 actions in the window of 20 seconds, let's say, and I'm running this again, you'll see this out going much faster. So you can see this going much faster than the previous one. And if I increase this to, let's say, 400, that means I can have 400 actions in 20 seconds. So it should be much faster. So you can see this going much faster here. So that's the idea of rate limiter. And I'll move on to the next use case. So far we have discussed 3 use cases: caching, session store, and rate limiter. And the fourth this is a very interesting use case, is about fast data ingest. The data comes so fast that MySQL or any legacy database won't be able to handle this amount of load. And we have seen this very often with some real-time analytics situation. So we have companies like Malwarebytes that collect all the malware information from all over the world, and no legacy database could handle that kind of load. And also we have a lot of IoT customers that use Redis to collect all the data, all the video, binary data, and all the sensor data that come in high volume, high velocity. And they do all the real-time processing before they send the data to a backend database like MySQL. Okay, and Redis has built-in data structures, again, list and sorted set, and also Redis also has pub/sub capability. So this is a built-in capability. I'll show a quick example. So the idea is there is a publisher and a subscriber. So in all 3 examples here, the 3 examples are based on pub/sub, lists, and sorted sets. You have a publisher and you have a lot of clients that have subscribed to this data. The idea is the publisher puts the data into a channel, or it puts the data into one or more sorted sets or list data structure, and all the subscribers receive all this information. And we have done a complete webinar on this topic. You can go to redislabs.com and you can see some real demos on all 3 ways on doing fast data ingest. And we have published a white paper. You can read the white paper and get all the details on how you can implement fast data ingest solution using Redis. I'll do a very quick demo of this. Here I'm doing an ingest using pub/sub. And just to give you an idea, I'm running Redis locally. So Redis is up and running here. You can see on the screen. And what I'll do is I'll run this ingest pub/sub, and this is collecting data from Twitter in real time, from Twitter Firehose. It is just getting all the data. You can see that here. And what I'm doing is I'm collecting some influencer information. If I get somebody with more than 10,000 followers, I'm just logging them as influencers, and I'll show you how I'm doing that. Okay, so let me see, I'll do a Z card on influencers. So far I have collected 24 influencers, and you can see this list, it may change, or there's a 25th. So let's see who has the highest number of followers. I'll do a query z rev range by score and answer influencers. The max I want infinity to, let's say, 100,000. Let's see if there's anybody with 100,000 with scores. So I have so many influencers here. Now, Rajasthan Royals, if you follow cricket, which I do, they're one of the cricket teams in India, and they have more than 100,000 followers, or they have about 1 million followers here. So you can go on doing here. You can see a lot of, so these are all the top influencers that we are collecting right now at this point of time, and this data is still running in real time. So that's just to give you a glimpse of how fast data ingest works. And with a database like MySQL, this is very hard to implement. It's very hard to process all this data in real time. So that's the whole idea, right? So you can do more with Redis. We have just shown you how you can do caching, session store, metering, and fast data ingest. You can go to our website and download the white paper, Why Your MySQL Needs Redis, and we have some detailed implementation. We have discussed all these use cases in much more detail over there. And also, Redis is popular in many other use cases. It's used as a primary database, and it's used in real-time analytics, messaging, and so on. There are many, many use cases, as I said earlier. It's like a Swiss Army knife for data processing. And with Redis Enterprise is the enterprise version that Redis Labs offers. It gives you high availability. So if you're designing session store and you don't want to lose data, take, for example, if you're filing your tax returns, your TurboTax, you don't want that to go down while you're editing your tax returns. And with Redis Enterprise, you get that kind of high availability. And also, we offer active geo-distributed database. So if you have data distributed across data centers, and if you want to do distributed caching or distributed session store, we have an active version. It's highly secure. Redis Enterprise is highly secure. And also, we have Redis on Flash. As I said earlier, if you're designing session stores with Redis, you cannot evict the data, or you cannot have a timeout on the data. It's not a good design to have a timeout. In that case, Redis on Flash comes to your help. You can extend Flash to store your data. Flash acts as your RAM extender, and you can just store terabytes of data in Redis. Right? And when we surveyed our customers on why they use Redis in a range of solutions, and you can see all the popular use cases here. User session store and high-speed transactions, they stand out. These are the two most popular use cases among Redis users. Right? And Redis Enterprise is available on cloud, VPC, and software. So I recommend you to go to redislabs.com and see our offerings. And cloud, you can sign up for free. We don't even ask you for your credit card information. So up to 30 MB, you can use Redis Cloud for free on redislabs.com. Right? So now is the time for our questions. I have some time to answer your questions. So let me open up the question panel. So I have a few questions here. The first one is, what other databases can Redis complement? Is it just MySQL? Well, that's a good question. This talk is about how you can complement MySQL with Redis. But as you saw, the discussion is about how you can complement any legacy traditional relational database with Redis. So MySQL is just an example. If you have any other database, Redis is definitely a complement. You can definitely boost the performance of your apps by using Redis. And the next question is, how do you handle JSON data in Redis? Can you store JSON in Redis? That's a good question again. Redis, as you know, is a key value store. And when you say keys and values are binary strings, and it's binary safe. So you can store any string object in Redis. So you can store any JSON object or even binary object in Redis as a value. And Redis has built-in Lua scripts. So you can use Lua scripts and access all the JSON objects individually. Or the other way is there is a re-JSON module. It is developed by Redis Labs. And if you're using Redis Enterprise, re-JSON comes built in with Redis Enterprise. Or if you're using open source Redis, re-JSON is again open source, and you can import re-JSON module, and you can use Redis to manage your JSON data. So that's again a good question. I see another question here. What structure are data structures, JSON, etc., etc.? I'm assuming you're asking about all the data structures that are supported in Redis. Now, Redis itself has some built-in data structures like lists, sorted sets, hashes, sets, hyperlog logs, and so on. But with Redis modules, you also have some additional data structures that you can support, like JSON. So that's, I hope that answers your question. The next question is, please compare Redis Enterprise to non-enterprise version. Okay, this is going to be a long, again, how does it stack up? This is going to be a long discussion, but to make it short, Redis open source is again, it's sponsored by Redis Labs, and Redis Enterprise is built on top of open source Redis, and Redis Enterprise is fully compatible with open source Redis. Now, keep in mind, Redis is a single-threaded process. So there's only one thread that runs inside the Redis process. If you're running Redis on a 16-core CPU machine, it runs essentially on only one core, and all the other 15 cores are not used at all. In case of Redis Enterprise, what you do is you shard the data, you divide the data, and Redis Enterprise itself takes care of it has a proxy, and it automatically directs all your calls to the appropriate shard. So you can make use of all the 16 shards available to you in case you have a 16-core CPU. So you can get a very, very high throughput. You can maximize your throughput. So that is just one example. And also you have Redis on Flash. If you're extending your data, you can. If you have large data sets, it saves a lot of money. It has active, and it has built-in replication. So you have primary and secondary. It does in-memory replication. So if your primary server goes down, there is an instantaneous fault detection, and your secondary server comes up almost immediately, and it's completely transparent to the application that this happened. But the ops people will get a notification that the primary has gone down and they need to revive. So there are many more. I advise you to go to redislabs.com, and you can see the advantages of Redis Enterprise. There is another question: is Redis SQL compliant? No, Redis is a NoSQL database. It is not SQL compliant, but you can use equivalent commands in Redis if you want something equivalent, but it's a NoSQL database with built-in data structures. I have another question here. It's a long question. I'll try to answer that towards the end. This is about on slide 20 where you updated. I'll come back to that question if I have time. Would you implement failover for Redis as a caching store for MySQL? Would you implement failover for Redis as a caching store? Yes, I would have a failover system for Redis whatsoever, because if you're using Redis for caching, and if you're having a large number of customers, and if you're caching a large data set, what happens is you hit the cache very often. And if your cache goes down for some reason, you run into a situation called cache stampede. And we have seen businesses getting affected by cache stampede. And we have, I cannot name those companies, but we have had many companies that came to us They were running Redis with no failover, and they had cache stampede situations. So they came to us for support, and they got Redis Enterprise. They purchased Redis Enterprise to avoid cache stampede from happening. So you definitely need a failover solution, even if you're using Redis for caching. Okay. If Redis is single-threaded, what is meant by saying Enterprise Edition allows you to use multiple cores? Yes, Redis is a single-threaded system, right? So if it is a single-threaded system, it attaches to only one core. With Redis Enterprise, what we do is we create multiple shards. So if you have 16-core machine, we create 16 different Redis processes, and we create different shards. So consider shard as a volume. If you have a big book like Britannia Encyclopedia, you divide your encyclopedia into multiple volumes, right? So similarly, what we do is we divide the big data set into multiple shards, into multiple volumes, and we make Redis run on all the cores, on all the CPU cores, and we get maximum throughput. So that's the whole idea. Okay. The next question is, my app needs to interact with Redis as well as backend MySQL. I'm not able to understand. So this seems like a very basic question, but I'm contrasting it with solutions where caching is more transparent. Again, it depends on your application. It depends on how you design your app. Now, if you have a data access layer, that gives you enough abstraction, so you don't need to modify your app to go and handle the caching. What you can do is you can just modify your data access layer or the data link layer, the abstraction layer, and keep it completely transparent from your app. Or we have some of our partners like Heimdall Data. They can offer you a solution where you don't need to modify anything. In case you have questions, you can contact our sales, and or you can contact Heimdall Data, and they should be able to give you some suggestions. Okay, and there are a few other questions. Well, let me go to the next question. What are the appropriate Redis server values for session cache versus hash cache users? I'm sorry, I don't understand the question. Now, Redis has built-in data structures, so so you can cache your data in key value store, or you can use any of these data structures like hash or set or sorted set or list. Depending on your use case, depending how you have structured your data, you need to use the appropriate data structure. Right? What languages are application APIs implemented in? That's a good question. Now, Redis has a very rich library of clients. We have clients in 60+ languages. So you could be developing your app in Java, Python, or Golang or Rust, or name a language. We have a Redis client library. So you can go to redis.io. That is the homepage of Redis, and you can go to the clients tab, and you can see all the clients. And if you're using Redis Enterprise, we also have clients that support SSL connections. Redis Enterprise is a secure way to hold data in Redis, and Redis Enterprise supports SSL. If you go to redislabs.com, you can look at our clients page, and you can see how you can have an SSL connection. And Redis itself is written in C programming language, so it's a very low-level implementation with extreme performance.
Great, Prashant. I think that's all we're going to have time for today. But before we go, I just want to quickly throw it back to you for one final thought or key takeaway you'd like to leave the attendees with today.
Thanks, Christina. Thanks, and we just have a few more questions, and what we'll do is we'll try to answer them. We'll try to get back to you with answers. Now, the key takeaways to conclude today's talk, there are 4 challenges. if you're using MySQL or with a legacy architecture, your data grows, your users grow, your apps grow. The challenges are how to minimize cost, how to achieve faster time to market, and how to keep your apps responsive, and then how do you manage with all the physical limits of your data. So that is so these are the 4 challenges, and we addressed these 4 challenges using Redis. And Redis is a great front-end database to address those challenges because it's simple, it's extremely fast, and it's known for its performance, and it supports the use cases. And we just talked about 4 use cases: caching, metering, session store, and fast data ingest. And also Redis, if you're an enterprise user and if you want enterprise-grade Redis solution, we have Redis Enterprise that gives you a lot more that you see on the right side of the screen. And thanks, Christina, for asking me about key takeaways. So that's it.
Very good. Well, thank you for a great presentation. Again, that was Roshan Kumar, Senior Product Marketing Manager at Redis Labs. And I would like to thank Redis Labs for sponsoring today's webinar, as well as the attendees for joining us today. Until next time, I'm Christina Cardoza with SD Times.